Hello and good morning, Doctor. My name is Muhammad Nassmyn bin Redzuan with matrix number 153966. I'm from group T10C. My partner's name is Putri Nur Shazana binti Abdullah Sani. So for the first question, which is an overview of the experiment that I have performed. So basically the experiment is about the projectile motion. The motion of, we have a steel ball. The projectile motion of a steel ball with different initial speed to determine the maximum projectile height and also the maximum range that it can reach. So for the first part, we are using 5 different angles, which are 25, 35, 45, 55 and also 65 degree, with the first initial velocity, which we use the PHY W is projectile motion experiment set. So we have 3 tension. So for the second tension, V0 2, third tension V0 3. So basically we use 3 different tension with 5 different angles to determine the height of projection and also the range. So what can we see from the experiment? For the first one, the maximum range will be reached when we use the angle of 45 degree. So if we compare between the angle 25, 35, 45, 55 and 65, we can determine that 45 degree is the optimal degree for the range to be maximum with the speed that we use. We can see that the graph starting from 25 will reach a certain range and it will increase when we increase the angle until 45 degree. So until 45 degree the range will be maximum, and after 45 degree if we increase the inclination angle the range will be decreased. So first it increase and decrease. That's why the graph look like a bell shape. So for the height, so for the projectile height, if we increase the inclination angle with the same speed, we can see that the height is increasing with the angle. We can say that the height of projection is increasing proportionally with the angle. After we have finished the range and also the height projection, we calculate the gravitational acceleration. So from the graph of range versus V0 square sine 2 theta, we get certain gravity acceleration, which is 8.528 plus minus 0.014. And for the second part, which we use the height versus V0 square sine square naught, which we will get the gravitational acceleration of 8.277 plus minus 0.002 meter per second squared. So from here we can actually achieve the gravitational acceleration, but with a certain percentage discrepancy. So our experiment may be a little bit not too accurate compared to the actual gravity, but still we get the gravity. So for part B, so we use the 3 different tension but with the same angle, which is 45 degree. So from here we can determine the maximum projectile range with the different initial speed. So from the graph we can see that for the first tension, the range, the maximum range is, let's say, 0.635 meter. So for the second tension, the maximum range is 1.269, and the third tension, the maximum range, which is 2.129. So it is proportionally increasing with the tension. So we know that 45 degree is the optimal angle for the range to be reached the maximum with different tension. So when we make a graph, a simple graph, maximum range versus initial speed, we can achieve by using the Linus function, we can achieve the gradient, which is actually the time taken for flight. But that's not really a good way to reduce the time taken for me, but still I did. So for the first question, what do you think is the best angle of projection to start the experiment with? So to start the experiment with, we need to start with a small angle, which is 25 is for me is the best angle, or 20, but 25 is okay because the range that we can obtain from the 25 degree is 0.518. But we need to consider the distance between the set, the projectile motion set, and the table the table where the projectile, the ball will landed. So we need to determine the distance first. So if we use much more lower angle, maybe we might not make it to the platform. So I guess 25 degree is the best angle of projection to start the experiment with, and in increasing it bit by bit. So suggest a way to accurately measure the height of projection. So for us, we use to take the video and make sure our eyes perpendicular to the ball where the height is maximum, and we take a look with the scale that we have there. So it is more accurate, better than during the motion we take a look at with our eyes. It is a bit not too accurate, but we use the video to accurately measure the height of projection. So suggest a way to determine the time taken to reach the maximum height. So we can use either formula, or we can just use a stopwatch. So stopwatch, from initial to the end, we use the stopwatch and divide by 2. So we can get, because the maximum height will be half of the time taken. So half of the time taken for the whole motion will be the time taken for the ball to reach the maximum height. So the second that we can use is the formula yt equals to v naught t sine theta minus 1 over 2 gt square. So by arranging the formula, so we can get the quadratic equation, which we can use to get the value of t. So the value of t there will be our value of when the height is maximum, because yt is our height. So if we use yt is the maximum, so we can get the t for the yt, which is the height, maximum height. So from the theoretical physics point of view, will the type of material of the ball affect the range and height of projection? Why and why not? So it will not affect the range and height of projection because the type of material is insignificant for it to be affected with the air resistance. Yeah, so it is quite insignificant unless that we use a certain ball which is full of feather, which is will have too much resistance towards the air. So that will affect the range and also height. But for the normal material, it will not affect the range and height of projection, because the range and height of projection will be affected by the degree inclination, and also the speed, the initial speed that we use for the projection, our motion. So that's all from me. Thank you.